Quasar K is another corneal lens that we produce at number 7 for the correction of keratoconus. The difference between the Quasar K and the Keratoconus 2 is that the Quasar K is an aspheric lens design. So there are no harsh junctions anywhere on the back surface of the lens. This provides really good fit and also can improve the vision. So who should we fit the Quasar K to? Generally mild to moderate keratoconics. Some of the more advanced keratoconics may be fitted, but generally the mild to moderate ones are more successful. Again, we recommend the use of the Contomac Optimum range of materials. And in terms of BOZR, we can arrange this from 5.7mm to 8mm, again in 0.05mm steps. Standard diameter of 8.8, but we can go up to a 9.6 radius, dependent on overall power and curvature. Power range again plus or minus 25 in 0.25 steps. Edge profile can be flattened or steepened in 3 steps. Each step is clinically significant, and the variation between each step is linear for the Quasar K. However, quadrant specific is not available with this design. So, when we're fitting a Quasar K, we're looking for a similar fitting pattern as we would with any other type of corneal GP. We're fitting the lens generally only loosely based on the keratometry readings or the simulated keratometry readings from a topographer. If we use this as a guide, early to mild, where we have a radius between 6.8 and 7.8, fit on flattest K. As it advances, then we'll fit on the average or mean K, and the most advanced between 5 and 6mm, again average K or slightly steeper, say 0.2 than average K. Looking at the peripheral fit, again we're looking for similar kind of clearance as we would to a conventional Quasar design. So we're looking for 50 or 60 microns clearance over about ½ mm width. As always, it's rarely and very unlikely to be symmetrical with keratoconic patients, so you will see some variation and some toricity in the fluorescein pattern. If you find that it's fitting very narrow or tight and that extends out to the edge, then increase that edge lift. If there are any areas of stand-up or you're seeing bubbles being formed underneath the edge of that, then reduce that edge lift. The lenses on the whole will always centre towards the apex of the cone, wherever that is likely to be. So if it's a central nipple cone, the lens will centre much easier into palpebrally. If the cone is inferior, particularly really deep inferior cones, that lens will stabilise in the inferior portion of the eye. If at all possible, increase the diameter to improve that centration. But this is one of the reasons why advanced keratoconics generally aren't successful with the Quasar K, because it's not possible to increase the diameter because of the increased steepening of the BOZR. If the lens is riding high, generally it's because it's flat or the edge lift is too great and the lens is being grabbed by the eyelids. This can create some bearing on the apex of the cone, which is not healthy for the patient in the long term. So in summary, corneal GPs are still a very good option for the ectatic cornea. They do give very good vision and they maintain excellent ocular health. The lenses can be made in a wide range of materials and they are highly customizable to ensure that the fit for each individual is accurate. And finally, the lenses are significantly cheaper than some of the other lenses that are currently available.